आज ही डाउटनट ऐप डाउनलोड करें। डाउटनट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Right. The question says the use of calculator is not permitted. The Boulevard Hotel has a particular way of numbering its rooms. The first room on each floor is numbered as the product of all floor numbers below it, starting from floor number 1. The ground floor is not counted. For example, the first room on the fourth floor would be numbered as 1 into 2 into 3, which is equal to 6. All successive rooms would be numbered 3 more than the previous room number. Thus, on the fourth floor, rooms are numbered as 6, 6 plus 3 which is 9, 6 plus 2 into 3 which is 12, 6 plus 3 into 3 which is 15, etc. If it is known that there are 6 rooms on each floor, how many numbers on the 15th floor are prime numbers? Right. So, according to the question, for floor n, right, the first room on that floor would have the number, the first room number would be the product of all floors below it, starting from 1, which means 1 into 2 into 3 and so on up till n, right? This is the same as, this will be n minus 1, all floors below it, right, below n. This term here is the same as n minus 1 factorial, right? So we can say that the first room number on any floor is the factorial of the floor number below it, right? And then after this, successive room numbers are, for example, the second room number, right, is n minus 1 factorial plus 3, right? And then the third room number will be this whole term plus 3, which means n minus 1 factorial plus 6 and so on, right? So we need to find out the floor numbers, the room numbers on the 15th floor, right? So for n equals 15, right, the room numbers will be n minus 1 factorial, which is 14 factorial, then 14 factorial plus 3, 14 factorial plus 6, 14 factorial plus 9, 14 factorial plus 12, and 14 factorial plus 15, right? So here we have 1, 2, 3, 4, 5 and 6 room numbers, right? Now we need to find out of these 6 room numbers which one is prime and how many of them are prime actually, right? So the definition of a prime number is a number which has only 2 factors. These factors are 1 and itself, right? So if we can prove that any of these numbers has more than 2 factors, then we can prove that that number is not a prime number, right? So we'll use this technique to find out which of these is prime. We'll start with 14 factorial. So the first one is 14 factorial. Now 14 factorial can be written as 14 times 13 times 12 times 11 and so on up till 1, right? So obviously, since these are all multiplied to each other, they are all factors of this term here, right? And since they are all factors, which means this number is not prime, since a prime number would have had just 1 and itself as a factor, whereas all these numbers are factors of 14 factorial, right? Now moving on to the second room number, which is 14 factorial plus 3. Now 14 factorial plus 3 can be written as 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1 plus 3, right? So this whole term plus 3. Now there's a 3 here, there's a 3 here. We can take that 3 common and we have 3 times whatever is left, which is 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 2, 1 and then plus 1 from this term, right? Now here we have two numbers multiplied to each other to give us this term, right? And none of these numbers is 1, which means these two are also factors of this term here, apart from 1 and this term itself. Therefore there are more than 2 factors, and thus this is also not a prime number, right? The same technique can be used to prove that none of these 6 numbers is a prime number. So for the third term plus 6, we can take 6 common here, right? And we'll have all the other terms in 14 factorial except 6 and then plus 1 here, right? 14, 13, 12, 11, 10, 9, 8, 7, 5, 4, 3, 2, 1 plus 1, right? Again there are 2 numbers here, right? So 2 factors here, which none of which are 1. Therefore this number will have 4 factors at least. This term 1, 6 and this term. Therefore this is also not prime. Moving on, 14 factorial plus 9. Again there is 9 present here, so we can have the same thing here, 9 and then whatever is left, right? And again these two terms will also be factors, thus this number is also not prime. The same is with the fifth term, 14 factorial plus 12. So we can have 12 common and the rest here, and then these two numbers will also be factors of this term. Therefore this is also not prime. Now the issue arises when we get to the last room number, which is 14 factorial plus 15. Now there is no 15 present in this term, in the 14 factorial term here, right? It ends at 14. The largest number there is 14, whereas here we have 15. So we can't take 15 common directly, but we do have 5 and 3 present in 14 factorial. So we can take both of these numbers common to get 15 common. So we'll have 14, 13, 12, 11, 10, 9, 8, 7, 6, 5 has been taken out. So 4, 3 has been taken out. So then 2, 1 plus 1, right? Again we have two numbers here which are factors of this term here, and none of these is 1. Therefore again this number is also not prime. So we've checked all 6 room numbers on the 15th floor and none of them is a prime number. Therefore the question asked for how many room numbers on the 15th floor are prime numbers. Therefore the answer is 0. Option A.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।